Okay, so last topic for our review of Chapter 3. We're still trying to find equations of lines, but I'm adding on a little bit more to the complexity because we're now introducing ourselves to this concept of parallel and perpendicular. So before we do anything else, let's talk about that first. Parallel lines, these are basically two lines that they don't intersect. They essentially have the same slope. Right, so if they have the same slope, whatever that slope might be, right, they're basically running parallel to each other, basically side by side. Their intercepts are different, but their direction's the same. So the key understanding, especially if we're trying to find the equation of a line, parallel lines have the same slope. So if you have the slope of one line and you're parallel, then you have to have the same slope. Perpendicular, a little tougher. What happens visually in a perpendicular situation is I have two lines that they actually are intersecting, but they're intersecting at what we call a 90-degree angle. And so the first thing you'll notice as far as slope is concerned, the slopes are not going to be equal because one's positive and the other's negative. So it turns out that for perpendicular lines, right, the slopes are what we say opposite reciprocals. So I think visually you can see opposite's important because one's positive and one's negative. Reciprocal, right, is the idea that we take a fraction and we flip it on its head. And we kind of see that happening here because one line has a relatively shallow slope, right, it's not increasing at all, and the other one has a very steep slope. So that's that idea that we're flip-flopping the reciprocal, or we're flip-flopping the fraction, getting the reciprocal, and then the opposite. So there's two things going on with slope. They're opposites reciprocals. So with that understanding, we can now tackle the problems. So we're going to try to find the equation of a line having a y-intercept at 0, 4. So that's good news. I already know what B is. And part A, we're parallel to the line passing through 1, 1 and 3, 8. So we want to use y equals mx plus b. I already know what b is, right? It's 4. The challenge is to find the slope. But they told me that the line we're trying to find is parallel to this other line going through these 2 points. So to find my slope, probably the best thing to do is to break out my slope formula, right? And so we got 8 take away 1 and 3 take away 1, and so we get 7 over 2. So my slope is 7 halves, right? And my intercept is 0, 4. So how do I find the equation of the line we're looking for? Well, since it's parallel, it's got to have the same slope, and it's going through that y-intercept. So plugging everything in, we have y equals 7 halves x, right, plus 4. All right, and so basically we found a line that has this y-intercept, but parallel to this other line. So there's our answer, and then to visually back this story up, right, so here's the line that we had, right? So we were given 1, 1, and then 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and 8. So here's the line that was given. The line we found actually goes through 0, 4, and it has the same slope. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So we can basically see that we found the right line. So here's the line we found, and there's the line that was given. We see that they are parallel, so we must have done a good job. Let's move on. Next problem. All right, so then in the next one, we're still trying to find the equation of a line that has the same y-intercept, but this time it's perpendicular, and the information's changing. I'm not giving you 2 points. I'm just giving you the equation of the other line. So again, we're trying to find y equals mx plus b. I already know that 0, 4 is my y-intercept. I just need to find the slope. And the only information that I'm given is that it's perpendicular to that given line there. So if we can find the slope of this line, then we can find the slope of something that's perpendicular by using my definition. So what's the quick way to find the slope of this line? Well, let's convert this to y equals mx plus b. So I'll subtract 2 from both sides, divide by -5, and so the line that's given, make sure you remember there's 2 fractions there. There's 2/5 x, and then that gives us a -2. So I have 2 separate lines here, right? And so this line has a slope of 2/5. So the slope that we want, here's a little notation, the perpendicular slope will be the opposite. So this is positive, my perpendicular slope will be negative, and then I have to take that fraction and reciprocal, flip-flop it. So the slope we want is -5/2, and the intercept we want is at 0,4. So putting this all together, my equation of my line is y equals -5/2 x plus 4. And keep in mind there's two lines here. Let me back up my story. So the line that's given, right, has an intercept at 0, -2, and then a slope of 2/5. So we'll go up 2, 1, 2, 3, 4, 5. Go up 2, 1, 2, 3, 4, 5. So here's the line that's given, right? That's that line. The line we found has an intercept at 4, but it actually has a slope. We're going to go down 1, 2, 3, 4, 5, and over 2. 1, 2, 3, 4, 5, and over 2. And so you notice that these lines do what they're supposed to be doing. They're intersecting at a nice 90-degree angle. So kind of a new wrinkle, the concept of parallel and perpendicular, right? Depending on how the information is given, right, we have to find the slope. Parallel lines will have the same slope. Perpendicular lines will have an opposite reciprocal slope. And then it's just basically reusing our famous y equals mx plus b to finish the story. So that pretty much wraps up chapter 3. Again, as usual, if you have any questions over concepts, please email me, post your questions on Canvas, get some people involved helping, or request a Google Meet session where you and I can talk one-on-one and talk more about these concepts. So let's move on from chapter 3 and start our 120 material. We'll see you guys in future videos.